Let's now plot the surface of x of z. We are given the sequence x of n, and we have already found that x of z is equals to z over z minus half. Remember that z is the entire complex plane, any complex number. So let's first generate the domain of this graph. Domain means the input points. This is the real axis. 0 is here, 1 is here, 2 is here. And along this line is at minus 2j. This is minus 1j. This is at line, this line is the imaginary axis, and this is j, and this is 2j. So we are interested to find where is the origin. So the origin is 0j, and the real number is 0. So this point in the middle of this circle is the origin. So I repeat now, along this line here, along this line here is the real line. Along this red line here is the imaginary line, and where they cross is the origin. So we have the surface of z, we have the plane of z. We're now going to plot x of z, the surface of x of z. Now x of z, you realize that if you plug in this equation, it's going to be a complex number. So a complex number have two parts, the real and imaginary. So we can't plot that. So well, we are reduced to plotting the absolute value of the complex number, and typically we're interested to plot it in the decibel format. So to plot in decibel, we take the log to the power of 2 of the x of z and 10. So the value that comes out is in the log scale. Now what we do is that we'll put in different values of z. The entire z-plane, any values that you want to put. In fact, we usually put a grid, and then we will substitute at the entire grid. And then out comes the surface. There, this is the surface of, this surface is the surface of x of z. Absolute value, log times 10. So this vertical axis that we have here is in the log scale or the dB scale. Now remember that this equation z over z minus half is only valid for absolute value of z greater than half. So what should we do? Well, first let's find out what does absolute value of z greater than half means. Look at the circle again. We'll go to the origin and we'll draw a circle. And this circle have a radius half. And the other side is minus half. And on this side is minus half j. And on the top is plus half j. And this is a circle with radius half. Remember we said that z must be greater than half. So any values of the surface, and then of course you can see the surface here, actually any values in this surface are invalid. So we should actually throw some of these away. These guys are all invalid. Only the surface outside this half circle is the valid region. Okay, then you say, how can we still plot this? Well, we are plotting z over z minus half. We're not plotting we're just plotting z over z minus half. Remember that z over z minus half is the correct answer for the geometric series only when z is greater than half. Lastly, can you see this red line, red circle here? This circle is a circle of radius 1 at the origin. This is a very important circle. It's called the unit circle. Unit here means 1, and it is a circle centered at the origin. So I plot it on the Z plane, as well as I draw this little thing along the surface. Now, later on you'll realize that we are very interested in this circle, because by studying this circle, we'll know whether the system is stable or not. We'll leave it to that later on. Now, lastly, I want to draw another plot. On the left, we have the 3D plot. On the right, we have the 2D pole and zero plot. What is the same is that first we take the whole Z plane and we draw the Z plane. So we now have the real part of Z from the horizontal line from minus infinity to infinity. And we have the imaginary part of Z from minus infinity to infinity. And in the middle, we have the origin. This is a simplified version of the 3D plot. How so? Well, let's plot where the pole is. The pole is at half plus J0. So we go to half plus J0 and draw a cross exactly at half plus J0. And when Z is equals to 0, we'll draw a 0 there, because this is Z over Z minus half. So when Z equals to 0 and when Z equals to half, something very exciting happened to this equation. When Z equals to 0, the whole equation becomes 0. When Z equals to half, the whole equation becomes infinite. So we plot these 2 points as crosses to represent the pole when it becomes infinite, and a circle to represent 0. So this is the pole and 0 diagram of X of Z. We also want to draw to show where the region of convergence is. So later on you'll figure out that the region of convergence in this example is absolute value of Z must be greater than half. So what we do is that we draw a circle, and this circle has radius half. In fact, you will touch that pole exactly. It says that absolute value of Z is greater than half. So where are they? They are at all these green lines over here. So these green lines are where all the absolute value of Z is greater than half. So in fact, what we see is that any of the surface along these green lines are valid. So these green lines are representing the regions of convergence for this X of Z. With that, we now see how we can plot a 3D plot from X of Z, as well as a 2D plot of pole and zero diagram. Thank you.